Good day. Today we're going to look at the z-scores of statistics. Now you have this statement above telling what a z-score is, but I'm going to focus on how to find the z-score in the lesson portion. To find this, we take the raw score data value, subtract the mean, divide by the standard deviation. The symbols that we need to know. We are used to sample population, mean, and standard deviation being x bar, s subscript x respectively. But for our entire population, for the mean, we're using mu, and for standard deviation, we're using sigma. To draw these symbols, you're going to add a little tail, and then draw a u for mu. For sigma, make an O, and a little curl that comes off. There's your symbols. Good enough. Example 1. Suppose a normal distribution has a mean of 10, standard deviation of 2. Find the z-scores of the following. For A, I'm going to have my raw data value 9. I am subtracting my mean of 10, and I'm dividing by the standard deviation 2. This is negative 1/2. Therefore, 9 is negative 1/2 standard deviations below the mean. I want you to try B, C, and D. So go ahead and pause the video and try those. I'll show you the answer at the end. Example 2. Now instead of trying to find the z-score, example number 2 gives us the z-score, and we're asked to find what our raw data value is. Alright, suppose we have a mean of 125, standard deviation of 7. What data value is 2 standard deviations above the mean? I don't know what my raw data is. Minus my mean, 125, divide by my standard deviation of 7, is equal to 2 standard deviations above the mean. Above is positive 2. If it said below, I'd use a negative. From here, I'm going to multiply by this 7, add the 125, but I'm going to get x is equal to 139. That is the raw data score. Pause the video and try part B. Example number 3. Now it's going to give us everything besides the standard deviation and ask us to find it. The mean is 22.6. The z-score for the data of 230, there's my raw number, is 0.2 for the z-score. What is my standard deviation? There's my equation. Sigma is going to be equal to 230 minus 22.6, 207.4, divided by 0.2. This is 1037. 1037 is the standard deviation on this problem. Alright, try part B. Now let's look at this using a curve. Now, the first thing I want you to notice, it gives you directions on the right. This is for a TI-84 or 89 calculator. So anytime it says normal CDF, we're going to use Desmos, and we're going to type normal dist for distance, parentheses mean, and standard deviation. Alright, what proportion of trees, and I've went ahead and filled out this chart based on the information above, the diagram. But what proportion of trees contains more than 150 feet? Alright, for 150 is in between these two. And I want to know what proportion, what percentage, is to the right of this graph. Alright, well let me show you now in Desmos. I'm going to type in normal distance, NORMALDIST. That has already loaded it. I'm ready to go. I'm going to put parenthesis. My mean value was 172, I think. 172. Standard deviation was something else. 12.4. I'm going to click cumulative probability on the bottom. I'm going to set my lower bound to the range of 150. It wants it all the way to the right, so I'm going to leave that as infinity. 0.962. So 0.962 of this population, which is 96.2%. B. What percent of trees contain between 175 and 190 cubic feet? Again, this is a Desmos problem. I'm just changing my maximum and minimum inside this, whatever you want to call this, range, I suppose. But 175. And I want it to go up to 290. 190. (331). This is going to be approximately 33.1%. Okay, that one's finished. Let me show you example number 2, and I'm going to let you try the remainder on this page. A healthy 10-week-old kitten has an average weight of 24.5, standard deviation of 5.25 ounces. The distribution is approximately normal. A kitten is designated as dangerously underweight when at 10 weeks it weighs less than 10 ounces. What proportion of kittens will designate as dangerously underweight? 10 ounces is whenever we have an issue. That's about here. Anything less than this is also included in dangerously underweight. Now, I need to figure out what is this percentage. So we're going to go to Desmos. Normal dist. And I need to change my mean to 24.5. My standard deviation is 5.25. And I want these values anything less than the 10-ounce kitten. So I'm going to say about 0.3%. About shows you the answer is too soon. About 0.3% of the kittens are underweight. Alright. I want you to pause the video and try these problems. Now I'll show you the answer key. This is all that I have for you today, and I hope you have a great rest of your day.